Everyone's asking, what was there before the Big Bang? What existed before the universe began? What was there before time and space? Wrong question. You're asking the wrong question. Not because you don't know the answer, but because the question itself doesn't make sense. It's the same as asking what's north of the North Pole. The question contains a logical flaw. And when Stephen Hawking proved this, he didn't just answer one of humanity's oldest questions. He showed us just how meaningless the question really was. This is neither philosophy nor word games. This is physics and mathematics. This is rigorous, calculated proof that the universe didn't begin in the way you think it did. Time itself didn't exist before the Big Bang. Before has no meaning. Let me show you why right now. More importantly, Hawking's discovery that changes everything we thought we knew about the origin of the universe. Let's start with what everyone knows, the Big Bang. Roughly 13.8 billion years ago, the universe began. Everything that exists, all matter, all energy, all space, all time emerged from an infinitely hot, infinitely dense point. Before the Big Bang, there was nothing. No space, no time, no matter, no energy. Literally nothing. And then, in an instant, everything happened. The universe came into existence with a bang. It expanded, it cooled. Over time, stars formed. Galaxies took shape, planets emerged, and eventually, life began. Our story started. This isn't speculation. We have evidence, overwhelming evidence. In 1929, Edwin Hubble discovered that galaxies are moving away from us. The universe was expanding. Now run this expansion backward in time. Everything gets closer together. It becomes denser. It gets hotter. And eventually, you reach a moment where all matter and energy was compressed into an infinitely small point. That's the Big Bang. In 1964, Arno Penzias and Robert Wilson discovered the cosmic microwave background radiation. This was the final echo of the Big Bang, heat left over from the initial explosion. And this heat fills the entire universe. It's everywhere. Its temperature is exactly 2.7 Kelvin. Just a few degrees above absolute zero. This radiation is direct evidence that the Big Bang actually happened. We've measured the universe's expansion rate. We've calculated the proportions of light elements formed in the first minutes. We've mapped the temperature variations in the cosmic microwave background. And everything matches up. The Big Bang theory isn't a guess or speculation. It's the most comprehensively tested, most solid theory in cosmology. But we have a problem. A very big problem. What happened at the very beginning? At the exact moment of time zero, at the singularity itself. That's where general relativity breaks down. The equations become meaningless. They predict infinite density, infinite temperature, infinite curvature. And you know what infinities in physics mean. Your theory isn't working. It can't explain what's happening. And worse, there's the question everyone asks. What was there before? If the universe began 13.8 billion years ago, what existed before that? What caused the Big Bang? What was there before time started? Most people think this is a reasonable question. Scientists thought so too. For decades, physicists assumed that saying before the Big Bang made sense, that something must have existed. A pre-existing state, a cause, an explanation for why the universe began. Hawking said no. The question is wrong. Not unanswered. Wrong. Asking what came before the Big Bang is like asking what's north of the North Pole. It's a category error. A logical impossibility. And he could prove it. Here's the key insight. Time is not absolute. Time is not a background stage on which events occur. Time is physical. Time is part of the universe. Time is woven into the fabric of space-time along with the three dimensions of space. Einstein taught us this. And if time is part of the universe, then time began with the universe. Time started at the Big Bang. There is no time before the Big Bang, because before requires time, and time didn't exist yet. Think about this carefully. You're asking, what happened before the Big Bang? But happened is a time word. It refers to events occurring in a sequence, before and after, past and future. These concepts require time. Without time, before has no meaning. It's not that we don't know what happened before the Big Bang. Nothing happened before the Big Bang, because there was no before. Time itself began at that moment. But you might say, okay, fine, time began at the Big Bang. But how did it begin? What caused time to start? What triggered the Big Bang? These questions still seem reasonable. Hawking showed they're not. Here's where it gets truly strange. Hawking proposed something called the no-boundary proposal, developed with James Hartle in 1983. The idea is radical, revolutionary, mind-bending. The universe has no boundary in time. What does that mean? Imagine the surface of the Earth. You can travel around it, but it has no edge, no boundary. You can't fall off. You can walk in any direction forever and never reach an end. Hawking said the universe is like this in time. The universe is finite in time. It has a beginning, but it has no boundary at the beginning. No edge, no singularity, no moment of creation in the traditional sense. How is this possible? Through something called imaginary time. In quantum mechanics, time can be treated as an imaginary number. This isn't science fiction. This is rigorous mathematics. In Feynman's path integral formulation of quantum mechanics, you can replace real time with imaginary time. The equations still work. In fact, they become simpler. When you use imaginary time, something extraordinary happens. The distinction between time and space disappears. Imaginary time behaves like a spatial dimension, and in this framework, the universe has no beginning, no boundary, no singularity. Think of it like the South Pole. On Earth's surface, the South Pole is just a point. It's not special. It's not an edge. It's not a boundary. It's continuous with the rest of the surface. You can walk to the South Pole, stand there, walk away. Nothing dramatic happens. In Hawking's no-boundary proposal, the Big Bang is like the South Pole. It's the point where time reaches its minimum extent. But it's not a boundary. It's not an edge. It's smooth, continuous, well-defined. In real time, the universe appears to begin at a singularity, at time zero. But in imaginary time, there's no singularity. The geometry is smooth, complete, finite, but unbounded. The question, what came before, doesn't arise. Because in imaginary time, there's no before. Time doesn't have an edge to go beyond. Now, you might object. Imaginary time isn't real time. We live in real time. We experience before and after, past and future. How does imaginary time help us understand the actual beginning of the universe? Here's Hawking's answer. Maybe imaginary time is more fundamental than real time. Maybe real time is what emerges from imaginary time as the universe evolves. In the very early universe, in the first fraction of a second, quantum effects dominate. Space and time are not yet classical, not yet well-defined. The universe exists in a quantum state described by imaginary time. As the universe expands and cools, it transitions from a quantum state to a classical state. Imaginary time becomes real time. Space and time separate. The distinction between past and future emerges. Causality begins, and we perceive time as flowing in one direction. But at the very beginning, before this transition, the universe had no boundary, no starting point, no cause. It simply was, existing in a quantum superposition of all possible configurations, described by what's called the Hartle-Hawking wave function of the universe. This wave function describes the probability of the universe having a particular geometry, a particular set of physical laws, a particular initial state. And when you calculate this wave function using the no-boundary proposal, something extraordinary emerges. The universe is most likely to be exactly the way we observe it, expanding, cooling, filled with matter and energy in the proportions we measure. The no-boundary proposal explains why the universe began in the specific state it did. It wasn't random. It wasn't arbitrary. It was the most probable quantum state given the laws of physics. The universe selected itself through quantum mechanics. But here's where it gets even stranger. If the universe has no boundary in time, then the universe wasn't created. It didn't come from nothing. It didn't have a cause. It simply exists. Complete. Finite in extent but without beginning nor end in the traditional sense. This sounds paradoxical. How can something begin without beginning? How can time start without there being a first moment? The answer lies in the geometry of space-time. In general relativity, space-time is curved. The curvature is determined by matter and energy, and near the Big Bang, the curvature is extreme. In Hawking's model, space-time curves back on itself. Time becomes space-like. The beginning of the universe isn't a point in time. It's a point in a four-dimensional geometry where all four dimensions are spatial. There's no time coordinate yet. Time emerges as you move away from this point. Think about the North Pole analogy again. Latitude is like time. As you move north, latitude increases. But at the North Pole, latitude reaches 90 degrees. There's nowhere further north to go. But the North Pole isn't an edge. It's not a boundary. It's just the point where north stops having meaning. Similarly, at the Big Bang, time reaches its minimum value. There's nowhere further back in time to go. But the Big Bang isn't an edge. It's not a boundary. It's just the point where before stops having meaning. This resolves the singularity problem. General relativity predicts that at the Big Bang, density and temperature become infinite. Infinities are unphysical. They indicate that the theory has broken down. But in the no-boundary proposal, there's no singularity. The geometry is smooth, finite everywhere, well-behaved. Quantum mechanics saves the day. At extremely small scales, at extremely high energies, quantum effects become dominant. They smooth out the singularity. They prevent infinite densities. The universe doesn't begin at a point. It begins in a quantum state spread over a tiny but finite region of space-time. Now, you might ask, how do we test this? How do we know if the no-boundary proposal is correct? This is where it gets difficult. We can't directly observe the moment of the Big Bang. We can't see back to time zero. The universe was opaque for the first 380,000 years. Light couldn't travel freely. We can't see what happened before that. But we can test predictions. The no-boundary proposal makes specific predictions about the initial conditions of the universe, the distribution of matter and energy, the spectrum of density fluctuations that eventually grew into galaxies, the amount of inflation in the early universe. And remarkably, the predictions match observations. The cosmic microwave background radiation has exactly the pattern of temperature fluctuations predicted by the no-boundary proposal. The distribution of galaxies matches. The abundance of elements matches. Everything fits. Does this prove the no-boundary proposal is correct? No. Science doesn't prove things. Science tests predictions. And so far, the no-boundary proposal has passed every test. It's consistent with everything we observe. It explains why the universe began in the specific state it did. And it does so without requiring a cause, a creator, or a pre-existing state. But there's more. In 2010, Hawking and Leonard Mlodinow published the Grand Design. In it, they extended the no-boundary proposal using M-theory. M-theory is a candidate for the theory of everything. It unifies quantum mechanics and gravity. It describes the universe in 11 dimensions. In M-theory, the universe we observe is just one of many possible universes, a multiverse. Each universe has different physical laws, different constants, different initial conditions. And the no-boundary proposal, applied in M-theory, predicts that all these universes exist. The universe didn't have a single beginning. It had many beginnings, many quantum fluctuations, many Big Bangs, creating many different universes. And we happen to live in one where the laws of physics allow for stars, planets, and life, not because it was designed that way, but because in a multiverse with infinite variety, some universes will inevitably have these properties. This is called the anthropic principle. We observe the universe to be suitable for life, not because it was made for life, but because if it weren't suitable, we wouldn't be here to observe it. It's a selection effect. We can only exist in a universe that permits our existence. Some scientists find this unsatisfying. It seems to give up on explaining why our universe has the specific laws it does. But Hawking argued it's the natural consequence of quantum cosmology. The universe selects its own laws through quantum mechanics. And in a multiverse, all possible laws are realized somewhere. The no-boundary proposal also addresses another deep question. Why is there something rather than nothing? Why does the universe exist? Traditional cosmology struggles with this. If the universe began from nothing, how did it begin? What caused it? Hawking's answer: the universe can spontaneously create itself from nothing, through quantum mechanics. In quantum mechanics, particles can appear from nothing. Virtual particles constantly pop into and out of existence. The vacuum is not empty. It's filled with quantum fluctuations. The entire universe is a quantum fluctuation. A fluctuation so large, so significant, that it became permanent. It tunneled from a state of no space, no time, no matter, to a state of existence. And it did this without violating any laws of physics. Because in quantum mechanics, anything that's not forbidden is mandatory. Given enough time, all possible quantum events will occur. But wait, I said given enough time. But there was no time before the universe began. How can a quantum fluctuation occur without time? This is where imaginary time comes in again. In imaginary time, quantum fluctuations can occur without real time. The universe tunnels from nothing to something through imaginary time, then transitions to real time as it expands. This is mind-bending, counterintuitive, hard to visualize, but it's mathematically rigorous. It's based on established principles of quantum mechanics and general relativity. And it's the only proposal that successfully explains the origin of the universe, without invoking something outside the universe. Think about what this means. The universe created itself, through the laws of physics, without a cause, without a creator, Without a pre-existing state, the laws of physics are sufficient to explain why the universe exists. Some people find this disturbing. It removes the need for a divine creator. It suggests the universe is self-contained, self-sufficient, complete. Hawking was explicit about this. In The Grand Design, he wrote, "Because there is a law like gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist." This caused controversy. Religious thinkers objected. Philosophers debated. But the science is clear. The no-boundary proposal is a testable, mathematical theory. It makes predictions. Those predictions match observations. This isn't philosophy. This is physics. Now, is the no-boundary proposal proven? No. We don't have a complete theory of quantum gravity yet. String theory and M theory are promising but not fully developed. There are competing proposals: the tunneling proposal, eternal inflation, cyclic models. Each has strengths and weaknesses. But the no-boundary proposal is the most elegant, the most mathematically complete. And it has Hawking's name on it. That matters. Because Hawking had a track record of being right about things that initially seemed impossible. Black holes radiate. Closed time-light curves don't form, and the universe has no boundary in time. Here's what you need to understand. The question what came before the Big Bang assumes time extends infinitely into the past. But time doesn't extend infinitely into the past. Time is finite. Time began. And at the beginning, time was not time-like, it was space-like. The concept of before doesn't apply. This is not a limitation of our knowledge. It's not a mystery we haven't solved yet. This is a fundamental property of the universe. The universe is structured in such a way that the question has no answer. Not because we don't know the answer, but because the question doesn't correspond to anything in reality. It's like asking, what happens when an unstoppable force meets an immovable object? The question is paradoxical. It assumes both can exist simultaneously, but they can't. If a force is truly unstoppable, there can be no immovable objects. If an object is truly immovable, there can be no unstoppable forces. The question contains a contradiction. Similarly, asking, what came before time began, contains a contradiction. Before requires time. If time began, there is no before. The universe doesn't have a cause, because causation requires time. Effect follows cause in time. Without time, there's no causation. This is the deepest insight of the no-boundary proposal. The universe is self-contained. It doesn't require anything outside itself to explain its existence. It's complete, whole, finite but unbounded. Like the surface of a sphere, you can describe every point, every region, and there's no edge, no boundary, no missing information. Some physicists speculate about what might exist outside our universe, other dimensions, a bulk space that our universe is embedded in, a multiverse of bubble universes. These are interesting ideas. But they're speculative. We have no evidence for them, and they're not necessary to explain what we observe. The no-boundary proposal explains the origin of the universe, using only the laws of physics within the universe. That's powerful. That's elegant. That's the hallmark of a good scientific theory. It doesn't invoke external entities. It doesn't require special pleading. It works with what we know. And it changes how we think about existence itself. The universe isn't a creation. It's not an artifact. It's not a construction. It's a self-consistent solution to the equations of physics. It exists because the laws of nature permit it to exist. And according to M theory, those laws may themselves emerge from deeper mathematical principles. So what was there before the Big Bang? Nothing. Not nothing in the sense of empty space, but nothing in the sense that the question has no meaning. There was no before. Time began at the Big Bang. The universe has a finite age, but no beginning in the traditional sense. It curves back on itself in imaginary time, forming a closed, complete, boundless whole. This is what Hawking discovered, not just an answer to an old question, but a demonstration that the question itself was based on a misunderstanding about the nature of time, about the structure of space-time, about how the universe began. The universe didn't come from anything. It didn't need to. It contains within itself everything necessary for its own existence. The laws of physics, the quantum fields, the geometry of space-time, all of it forming a coherent, self-consistent whole. And that's not a limitation, that's liberation. It means we can understand the universe completely. We don't need to invoke mysteries. We don't need to appeal to the unknowable. Everything the universe is, everything it does, can be explained by the laws of physics operating within the universe. That's the power of the no-boundary proposal. It closes the circle. It completes the picture. It shows us that the universe is exactly what it appears to be. A natural, physical system governed by mathematical laws. Nothing more. Nothing less. And that, in its own way, is far more profound than any creation myth, because it's real, it's testable, it's based on evidence, logic, and mathematics. It's the truth about where we came from, not a comforting story, but the actual structure of reality. So the next time someone asks you what came before the Big Bang, you'll know the answer. The question is wrong. There was no before. Time itself began with the universe. And in Hawking's elegant formulation, the universe has no boundary, no beginning, no cause. It simply is. That's the answer. And it changes everything.